All right, so properties of logarithms. So we are just kind of getting used to logarithms, what the graphs look like. We haven't done a lot with logarithms yet. We kind of got used to how a logarithm is related to an exponent. They're inverses of each other. So if you had something like 5 to what power equals 25, that's an exponent. And then we are learning about how that would be written as a logarithm. The 5 is called the base. And when you write it, the logarithm, you take that 5, that base, and you drop it down small. Okay, so the base is right there. It's just written small. And then you swap these around. So we've had like teachers say, just to kind of help you remember, that you drop the base. They call it like drop and swap. Then you swap things around. So it says log base 5 of 25 equals x. Okay, so they say drop and swap. Just kind of, maybe that'll help you remember it. Drop the base down, swap these other things around. So we've learned the logarithm, just a little intro to it like that. And what do you guys think? What is log base 5 of 25? What would the answer be for that? What would the x be? It's asking the same as this. 5 to what power gives you 25? That's what a log asks. Yeah, it's 2. That's right. Yeah, a couple of you got it. So yeah, the answer is 2 for that one. So a lot of times you can just look at them and see it like this. If I gave you log base 5 of 25, you're like, oh yeah, that's 2. So here's another one. What if I said, what's log base 3 of 9? What would that one be? So try to keep in mind that these logarithms are asking you to figure out the exponent. It's asking like 3 to what power gives you 9?
2 again?
Yeah, 2 again. So I gave you easy ones. So yeah, that answer is 2. Okay, so that answer is 2. But there's some questions that ask you something kind of weird. I'll give you an example. What if I asked you to do log base 3 of 8? Then what the heck is the answer? Look at this one. Okay, this one was pretty obvious. 3 to the second power gives you 9. Do you know how to do something like that? Or are you stumped? Probably stumped would be my guess. But if you think about it, 3 to the second power gives you 9. Somebody, like we asked the same question to our Algebra 2 kids, our students in Algebra 2, and you're thinking 3 to what power gives me 8? That's weird. You might know, is it going to be an answer bigger than 2 or smaller than 2? If log base 3 of 9 was 2, is this answer going to be bigger than 2 or smaller than 2? Log base 3 of 8, what do you think? It's going to be bigger or smaller than the previous answer?
Smaller.
Yeah, smaller. Okay, so what you have to do to solve something like this, you know it's going to be smaller. That's awesome. You have to do what's called a change of base formula. Change of base. It's actually pretty simple. You're going to do, I'll just kind of show you how you would do this one. You just do log of 8 divided by log 3. You're like changing it to base 10 is what you're doing. It's like log base 10 of 8, log base 10 of 3. And all you do is grab a calculator and punch this in. There's a log key. Most calculators have a log key that'll do log base 10. Like they don't have a little tiny base number by it. On my calculator, it's just this log key right under the second key. There's a log key. So I would just type in log of 8. I hit log 8. And it's like, I don't know if you can see this. It's like it has a parenthesis. You have to close the parenthesis. I know it's kind of blurry. Log of 8, close the parenthesis, divided by, let's see if I can focus it. and then divided by log 3. And you just do it on a calculator, and we got 1.8927, so equals 1.89, yeah, focus that in again. I know when you focus this stuff. Okay, so 1.89278, so 28 or something like that. I'll just round it off to 4 decimals. So you guys were right. You said the answer was going to be smaller than 2. See, it's a decimal. So you have to use the change of base formula when you have weird questions that you can't just mentally do. It's not going to come out to a nice whole number. So we have to use this change of base formula to figure it out. They're really not too bad. It's just knowing how to set it up. And the base, like the base on this one was log base 3. That kind of goes in the bottom, goes to the basement, goes to the bottom of the fraction. Since it's the base, goes to the basement. I don't know, try to help you remember it. So let's do one more of those. If it said like log base 4 of 25, if you had to solve that one, you would just grab a calculator and do log of 25 divided by log 4. Because you can't think anything about 4 to what power would give you 25. That's not going to come out nice. So that's why the change of base formula is helpful. So again, you just grab your calculator, type in log of 25, close your parentheses, divided by log 4. And it comes out to 2.3219. 2.3219. So yeah, you get decimals on these. And you need that calculator because it's not something you can mentally do like this first one. I could do that one mentally. 3 to the 2nd power gives me 9. I'm like, oh yeah, I got that one easily. Can't do these in my head. Need a calculator. Okay, so that's the change of base formula. The base number, like the bottom number, goes down below, goes to the basement. Log base 4, that now is in the bottom, log 4. So that'll help you kind of set them up. Okay, so that's your change of base formula. Okay, now we're going to learn some other properties of logarithms, other properties that you're going to have to use. Okay, so we got a couple different properties of logs, I'll just put. So one of them is called the product property. Okay, the product property, how that goes, and we'll just kind of give you a quick example. Okay, I'll put log base A of UV. Okay, it's called a product property. So it's called a product because like what I have here, I said UV, that's U times V. I have UV, U times V. Well, what the product property does is you can break this apart. You can like expand this out. They say you can expand this into log base A of U plus log base A of V. The product property, when you have times, you expand it out. It's addition. It expands into addition. And now what's interesting about these properties is they go both ways. If I would have started with something that's addition, like these over here, if I would have wrote that first, I could put it back together into this. I could put it back into log U times V. Now, these properties come from properties of exponents. You've probably heard before that when you multiply and you have exponents, you add the exponents. That's where it's coming from. When you multiply, it's like you can add things. Like you've done in the past, like x to the 2nd power times x to the 5th power. And then you add the 2 and the 5 and you get x to the 7th. When you multiply, you can add exponents. It's the same with logarithms. When you multiply, you can add logarithms. So that's the product property. Then there's another property called the quotient property. Quotient means divide. So there's a quotient property. And when you're dividing, like if you have log base A of u divided by v, like a fraction like that, u over v, move this down a little, that turns into log base a of u minus log base a of v. It turns into subtraction. So the two properties so far, product and quotient. Okay, so the first one had times, product was times, and see how that turned into adding? And now this is dividing, turns into subtraction, subtracting two logs. And again, these can go both ways. If I would start with a subtraction problem, I could tell you to put it back into one logarithm. I could tell you to condense it and put it back together into something like this. And we'll try a few, you'll see. You can like put it back together. If you get it presented with a subtraction of two logarithms, you can put it back together into a fraction like that. So they go both ways. So that's why I'm making my equal sign like an arrow. It goes either way. And then the third property is called a power property. So there's a power property, and how that one works, I'll write this one out. Log base a of u to a power to the n power. Log base a, something like something to a power, u to the n power. So what happens with the power property is that exponent I added, that n power, put u to the n power. That n moves. It can go, it's kind of interesting, it can go out in front. It turns into n times log base a of u. So this one I kind of like to circle it with my red pen and show like it moves, it moved it over here, it moved it out front. Like you can pull it out front. Or vice versa, if you start it with it this way, if it's already in front, you could like put it back over to the other side. Like you could move this and put it back over here. So it's kind of, that one's kind of interesting one, the power property. So when you have an exponent on here, it can go out in front. And again, this can go either way, vice versa. If you had started with something in front of your logarithm, it could go back over and go at the end as a power. So these go either way, so I'm making my equal signs into arrows. So it's kind of interesting, these properties, kind of different. So let's try like a property like that. So when you go from something, this is a single logarithm, and then you break it into two things, that's called expanding it out. That's called expanding it. So they're going to ask you to expand some. And like I said, it can go either way. If you started with the two logarithms and they want you to put it back together into one, that's called condensing. So you can either expand it out into two things or put it back together, condense it into one thing. Same on the quotient property. This side's like the condensed side because it's just down to one logarithm, or you can expand it into two, like that. And even the power property, they say that this side over here is the expanded side because now you have something times the logarithm here. It's kind of, but here it was all in one, just logarithm of all this stuff. This was condensed. Yep, so this side's the condensed side. So on all of these, this side, the first side I gave you was the condensed side, and the second part it was expanded. So let's try a couple of these. We'll try to use these properties and show you what you're going to be encountering. So you're going to see things like, they'll tell you to expand something. They'll tell you to expand log base 4 of 5x to the third y. Look at that. Okay, so expand log base 4 5x cubed y. So when you look at this, you have to think, well, what's happening here? Is this addition? Is this subtraction, multiplication, division? Well, first I just think, what do I see here? Well, it's 5. Isn't that 5 times x to the third and then times y? Sometimes just putting those dots there helps me. I'm thinking, oh yeah, that's a times problem. 5 times this times this. That's multiplication. So that's makes me think about multiplying is product of stuff. A multiplication, that's product. So we should be thinking about the product property when we're doing this one. So it's going to be log base 4. It's going to
property and power property, right?
Yeah, we're going to get to another property. There's more than one property here. Awesome. Yep, so in the chat, Tori was saying there might be another property too. Yep, so I'm starting with the product property. Yep, and we're going to have another property also. That's great. Because she's seeing a power on this x to the third power. So it's log base 4 of 5. So if it's times, well, we got to think of our properties. If it was times something, we're going to expand it into addition. See that? We're going to expand it into addition. So it's going to be log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. There was several things being multiplied there, so it breaks into several logarithms being added. Okay, then Tori beat me to it. That's right. Then we have a power right here, x to the third power. So now we can do the power property also. And this is pretty easy. You just bring this 3 in front of this one. Just kind of put an arrow, that'll help you see it. And then the problem will be finished. Then that's all there is to it. So the answer is log base 4 of 5 plus, and then you bring the 3 in front of this one, 3 times log base 4 of x plus log base 4 of y. So it started, it said log base 4, and they still all say log base 4. Because some people have asked about that. What about that little 4? They all just, keep saying it's kind of just a common theme, that log base 4, just keep saying log base 4 of this, log base 4 of that. And that would be the answer for that one that's expanded out. Let's try, I'm trying to think how many examples I want to do of each one. I'm looking at the time and stuff. I'll do one more expand one. So let's do one more of these kind. So let's say log base 3. Let's do 4x squared over square root of y. So right away, you just, I don't know, just pops into my mind that I see a fraction. That's the first thing I think of. Okay, great, I have a fraction. So if I have a fraction, if we look back at our properties, if I have a fraction, you should be thinking about this quotient property. If you have a fraction, it's going to turn into some subtraction problem. See that? Okay, so hopefully this makes it pretty easy if you just keep referring to those properties. So this one would break apart. Log base 3. Put the numerator, the top said 4x squared, minus, because the fraction turns into minus, and it's going to be log base 3 of square root of y. So far we did the quotient property. But yeah, now we might not be done. There might be more properties involved. We did the quotient property first. That helped with our fraction, broke it into 2 logs that have subtraction. Okay, but we got more going on here. Probably might even use every single property. Because now we have 4 times x squared right here. 4 times x squared. So this is going to break apart. This would be log base 3 of 4 plus log base 3 of x squared. because the times, remember that's the product property, turns into addition of 2 logs. Then I have this last one, minus log base 3. Now some of you, do you know another way to write square root? Instead of writing square root of y, did you know you can write it with a power? Do you know what power it is instead of writing square root of y? Some of you might know that. I want to write y and put the power. What power is associated with square root? I don't want to write square root of this. I want to put the power for it.
Ooh, just 2, right?
Not 2. You're close though. Because it's not y squared. It's close. You're close. You're pretty close. No, not 2. Yeah, somebody got it. 1/2. Hannah got it. Good job. Yep, a square root is the same as 1/2 power. Square root is the same as 1/2 power. Like 1/3 power is cubed root. 1/4 power is the 4th root. They're different roots, so yeah, it's a fraction. Yep, square root is 1/2 power. So I'm rewriting that. Okay, now we're almost done with this one. So we have these powers. This power is going to go in front of here. And like I wanted to rewrite this to the 1/2 power because then I knew I could do the power property and put the 1/2 in front of this one. Deal with that power property. So now I think I got it. Log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. And that one's done. So what do you think about that? Anything confusing? I know it's a lot. There's a lot of properties. You have to do like 3 different properties and spread it all out. And then these problems can go the other way also. You can condense something big like that. You could put it all back together. So let's do one condensed one. Okay, I'll do... think of which kind I want to do. Okay, I'll do this one. Condense 1/2 ln natural log x plus 3 natural log x plus 1. So these properties work with the log, the common log, or log base, whatever. It also works with natural log, ln, natural log base e. The properties work no matter what kind of log you're dealing with. So this is natural log base e. Still the same properties will work. So like I was saying, this is like go back the other way. We have it all expanded out. We want to condense it into a single logarithm. Condense into 1 logarithm. That's when you see the word condense, it's like put it back together. It condenses it into a single logarithm. So if you see a number in front of the logarithm words, that's the power that's going to have to go back over at the end. So I try to do those first. You kind of might notice that when I expanded it, I did that power thing last and brought those over last. So if you go the other way, you have to do those first. You have to bring the powers back over. So it's going to be natural log of x to the 1/2 power plus natural log x plus 1, that's in parentheses, that'll be to the 3rd power. See, that's going to come back over. Okay, now addition. I can flip back to my notes here. This addition kind is going to go back together, condense back together as times. See that? Addition, like log of u plus log v, it went back together log u times v. Okay, so the one we're doing, it's addition, so it's going to go back together. So since it's addition here, these things are going to go back together like times together again. So hopefully you kind of understand. So it's going to be natural log ln, so it's going to be x to the 1/2 power, and then x plus 1 to the 3rd, just times. So it's just like next to each other like that. And if you want, we were just talking about 1/2 power. That's the same as square root of x, and then x plus 1 to the 3rd. you could have it like this. Natural log square root of x times x plus 1 to the third. So hopefully you see it's not too bad. It's not horrible. Just getting used to manipulating things with these properties. Okay, and then I'm going to show you just a couple where you have to solve. And then we're about good to go and start working on the assignment on this. I want to show you solving just a couple interesting ones. Okay, I'm going to show you something like this. Solve log base 5, and then it has the cubed root of 5. Solve log base 5, and then cubed root of 5. We'll do that one, and then I might as well write the other one. We're also going to solve natural log e to the 6th minus natural log e squared. So if you use these properties we learned today, sometimes makes it easy to solve things too. So this one, log base 5. Okay, now this is the cubed root of 5. So it's just like the one with the square root. There's a different way to write cubed root. Instead of writing a box around this number 5, there's a different way to write cubed root. You can write 5 to a certain power. Yeah, 1/3 power. Good job. So you want to think of that, this box around this, you can write it as 1/3 power, because then you can do the power property we just learned, and you can bring that 1/3 out in the front. So then you have 1/3 times log base 5 of 5. Now you can solve. Do you know what log base 5 of 5 is? This is asking 5 to what power gives you 5? Good job, it's 1. Log base 5 of 5, that's 1. So now I just have 1/3 times 1. So my answer is 1/3. Yep, 1/3 times 1, that's 1/3. So see how the property, like a power property, kind of helped us get that 1/3 out in front, and then this is simple to solve, log base 5 of 5. Same on this next one. We have natural log e, and then we have these powers, e to these powers. Natural log e to the 6th minus natural log e to the 2nd. You can use some of the power properties. Actually, this one you could do two different ways. You might have noticed it's also subtraction. I've seen people do it where the subtraction property, the quotient property, had subtraction in it. So actually I know two ways to solve this one. Right? I don't know. It really doesn't matter. I could do it both ways. So one way to do it is bring this 6 in front and have 6 natural log of e. Same thing with this 2. Bring this 2 in front minus 2 natural log of e. Well, what is natural log of e? That's the key question here. When you're in natural log, it has a base e. So when they ask you natural log of e, they're asking like e to what power gives you e? Do you know what the answer is for that? Natural log of e? Well, you can do it on a calculator too. Look, I'll show you. Grab natural log is the second one down, natural log below that second key. Natural log, and then I'll find the e key. It's like, what's the natural log of e to the first power? E to the first power. It's just 1. Natural log of e is just 1. It's like e to the first power gives you e. Yeah, so it's just going to be 6 times 1 minus 2 times 1. Well, 6 times 1 is 6. 2 times 1 is 2. 6 minus 2, that would be 4. There's another way you could have done that one, like I was hinting at. It was a subtraction one. It was a subtraction problem. You could have made it into a fraction. You could have used that quotient property. You could have done ln e to the 6th over e to the 2nd, because it was a fraction. Subtraction, fraction. I know, subtraction turns into a fraction. And you could have wrote it like that, natural log of e to the 6th over e to the 2nd. And when you have a quotient, you can subtract your exponents. So it turns into natural log e to the 4th, 6 minus 2 is 4. And it's the same thing, the 4 goes in front, 4 times ln e. And like I said, natural log of e is 1, 4 times 1 is 4. Still the same answer. You could have done it a different way. I know I did it quickly, but it's like the same but different. Okay, what else? There's one more thing, and then I think I can let you start working. There's one more thing where you kind of can manipulate things. Like they're going to tell you to sometimes use other logs to like manipulate a logarithm. So like use log of 3 and log 5. Use like two other logs to write log 75 a different way. They ask you to do this. It's like a manipulation thing. They ask you on your assignment to use a couple other logs to write, for an instance, this one, log of 75, to write this one a different way. So it's all about, it's actually kind of all about seeing if you could break 75 apart. Is it related to these numbers that they're giving you? That's all it's about. So if you think about what they gave you, they're saying to use these up here to write this a different way. Use log 3 and log 5. Well, think about it. Does 75, it's a big number, does it break apart into some of these smaller numbers? Does 5 go into 75? Like 5 times what? Okay, I'll grab a calculator. What's 75 divided by 5? I got 15. And then 15 is 5 times 3. So you can see that 75, you could break it into 3s and 5s that they gave you. So it's like 5 times 5 times 3. So you could rewrite this one, log of 5 plus, okay, wait, I want to think of it, I don't know. Okay, never mind, I'll just do what I was going to do. I think of 2 ways to do it again. I'm thinking of 2 ways I could have done this. So that's why I kind of paused. I'm thinking, I could do it this way or this way. So I have log of 5 plus another like log of 5 plus log of 3. I almost stopped myself because some of you might have thought of it too. I could have wrote 5 squared. But it's going to come out same answer. If I have a log of 5 plus another log of 5, it's kind of like a like term thing. Isn't that 2 log of 5s? See that? Plus log 3. I would have got the same answer if I would have put 5 squared and then brought the 2 over. See like 5, I could have done log of 5 squared, and then here I'll just use my red pen, and then I could have brought the 2 out here and it would have said 2 log 5. See how it's the same? One of these plus another one of these makes 2 of those, 2 log 5s, like terms. I was just thinking of 5 squared is another way I could have shown it. Yeah, so they have you manipulate sometimes and use other logs to break something down.
Why didn't we use 2 things they wanted us to use?
We did. We used the log 5 and log 3. I could have written it log 5 squared. I'm using the 5 still though. I have 2 of those 5s. Times a 3. So I'm using a log 5 squared plus a log 3. I'm using both. Yep, I'm using both. I don't know what she means. I'm not
So
sure.
how does that equal to log 75?
2 log 5. I'll write it again. How does it equal to 75? It equals to 75 because if you were going to put this back together, it would go back. This power would go back over here. You would condense it back again. This power would go over here, and that's 5 squared. That's 25. 25 plus is times. When you put it back together, addition turns back into times.
Okay, I see.
Yeah, it's weird. See how it was times, and then it broke into addition of logs? So if you take addition of logs and put it back together, it would be multiplying again. It's weird. Yeah, it's kind of weird. Here, I'll do one more. One more of those weird ones. So again, use log 3 and log 5 to write something else. I'll move that up, sorry. Get the camera all set. Okay, use log 3 and log 5 to manipulate a different problem. To rewrite log 9 over 125. So you're going to use these up here to rewrite this a different way. Yep, to rewrite this a different way. So think how these 3's and these 3 and 5, how is it related to the numbers they gave you? What about 9? Does 5 go into 9 or 3 go into 9? Rewrite 9 using 3's or 5's. It's kind of weird, isn't it? So log, okay, so what do you think? How are you going to rewrite 9 using these numbers up here?
3 squared.
Yep, 3 squared. 125, doesn't 5 go into that? Think of that. How do you, another way to write 125 but use 5. Does 5 go into it? Break. So I just sit here and like I take 125, like use a tree, break it down, divide that by 5. See what happens. 125 divided by 5, that'd be 25, divide by 5 some more. See how many 5's are in 125? It'd be 5 to the 3rd power, yep. So now we're going to use the properties. They would use the properties and kind of expand this out. So then it would be log 3 squared. Then what do we do since it's a fraction?
Subtract.
Good job. Subtract. So it'd be log minus log 5 to the 3rd power. And then you use your power property, and these powers go in front of each one, and then you're done. 2 log of 3 minus 3 log of 5. So see, you're using log of 3 and log of 5. Yes, it has a power number still in front, but you're using those log 3 and log 5 to manipulate it. Oops, I gotta move that down a tiny bit so you guys can see it. All right,